All right, we are looking at radicals, where you're probably real used to something such as the square root of 64 is 8, because 8 times 8 is 64. We don't write it with the square root, but there really is a little 2 right there. So just kind of keep that in mind. I know you love fractions, but you can do the same thing with fractions, because I can rewrite this as the square root of 1 over the square root of 4. The square root of 1 is 1. The square root of 4 is 2. Or if I just thought about it, 1/2 times 1/2 would give me 1/4. Don't worry if you see like a negative sign out front, because you would just still leave the negative sign out front, and then 11 times 11 is 121. But if you see a negative sign inside, that's a uh-oh, not a real solution. That's when you get these crazy math people get into those imaginary numbers, which we're not going to get into right now. But so that would not be a real solution. As you could probably guess, we're going to throw in some variables. You can, because on the product rule, you can actually separate these, and you could rewrite them as square root of 4 times the square root of x to the 8th. If I can show you 2 ways to work this. So we know the square root of 4 is 2. If you remember exponent rules, when you multiply with the same bases, you add. So that makes sense, right? 4 plus 4 would be the same here. Remember, the rule of a square root is if there's 2, you just simply take that out. Now, if you know the rules of exponents and radicals, so let me go back to this piece right here. Remember, I told you there's a little 2 outside. You can rewrite this as x, the power stays up top, what's on the outside goes on the bottom, and look at that. That gives you the same answer. So it's just another way if you know the exponent rules with radicals. All right, sometimes these don't work out so nicely and perfectly. What I mean by that is, like, what's the square root of 50? I don't know any 2 numbers I can multiply to get 50. However, my brain goes, I know 25 times 2. Remember, I can separate these, and the square root of 25 is 5, and you just can't do anything with the square root of 2. So you're always looking for a perfect square inside of there. And so if I had something like even a number here on the outside, and my brain goes, well, I'm trying to think of a perfect square. I know 4 times 6 is 24, right? And so that gives me my perfect square right here. I have a -9. The square root of 4 is 2. Can't do nothing with that. Now I can multiply those to get my final answer. So what you can see is you're simplifying here. I can even do, again, your favorite with fractions. I can make the top the square root divided by the square root of the bottom. I feel good about the bottom there, right? But I'm not really sure about the top. But whenever I see something that ends in a 5, I will be honest with you, I pick my calculator up and I divide it by 5. And I see that 25 times 5 is 125. The square root of 25 is 5. Can't do anything with that. And then I get my answer. So these are just kind of the basics of the radicals. I don't want to say square roots, because sometimes you can have different roots. And I will add some more examples for your viewing pleasure.